We are here to present Wage Wizard, which is a salary prediction model. So, for our final data science project, after researching extensively, we were just scrolling around LinkedIn, like, pop-up linking notification in email, and we kind of realized that a lot of the jobs there actually, they don't really show any definite salary range that you can estimate that, okay, if I apply to this job, I can gain this and it can help me attain this, and this. Like, it's not really helpful at that point. So we decided to actually create one. We created a predictor, like a salary prediction model, that we provide you with a salary range based on the various criteria, so the various information that's provided on the job posting. And as you can see, we started by finding the accurate data, and we also thought the city and the company itself are very important, so we find those information too. And we were cleaning the data based on various criteria, like dropping unnecessary column, selecting some particular countries to work on, renaming some colors for easy identification, for easy use, and also cleaning some colors because some of them were actually dictionaries. A company profile that was dictionary, and the benefits too. So we also, using the benefits, for instance, we created several other columns using true or false kind of ways, just to make it in such a way that it's more easy to use and more easy to analyze, and also more easy to do some EDA before doing some rapid data integration and analyzing the whole data in a very extensive EDA.
Okay, for our EDA analysis, we did various graphs and diagrams in order to understand how different factors affect salary predictions across different countries, the skills requirements for different jobs still across different countries. And under each of the graphs in the collab notebook, we gave a brief summary of the insight we got from the EDA analysis of that particular graph. And at the end of our EDA analysis, we had some preliminary analysis which provides a number of insights useful in guiding the prediction of individual salaries, right? The variability in the minimum and maximum salary, which gives us an indication of how relevant job title, qualification, job experiences are to compensation. Then we also found out insignificant variation in salaries across cities and countries, which puts forward a case that geographic location may not be a major feature in this data set. And then with flexible working and bonuses only having a very small coefficient in the model, and it will be appropriate for us to focus on job related factors and salary predictions rather than the benefits when we start actually building our predictive models. So this is it for our EDA analysis, and you'll find an extensive data summary in the notebook.
Okay, after the EDA, just to make sure that everything that we saw actually made sense, we did an extensive feature engineering using the PC. As you can see, we encoded the data using label encoding just to make it way a little bit easier. And we now use random forest, key-based, and PCA, just to make sure that whatever trend we saw is actually what's there and what's making sense. And after analyzing the EDA plus this feature engineering tool, we came up with the best 15 features that we got before going into our very first model.
We suspected there might be a linear relationship between the features and the salary, which was most likely the case. Thus, we decided to create a multiple linear regression model from scratch. This enabled us to use the different features to compute the prediction. But first, we had to scale the different features and labels in order to prevent the gradients from exploding when you're trying to tune the parameters. So we did the scaling. We created the model class that's going to handle the creation of the model and the training. And then we tested and verified the accuracy, which happened to be about 92% for the minimum salary range and the maximum salary range, as you can see on the graph.
Okay, and for the second model now.
So we went with the second model, which is the voting regressor. Then most of the voting regressor we dealt with was using the research CV on XGBoost, random forest, decision tree, and then the gradient boosting. And with this, what our main purpose is to make sure that we get the model that actually is more performant than others. And with this, to calculate the error, because we understood that the errors are also a determinant factor in getting the best model, we use the mean squared error and the mean absolute error. So going with the graded boosting, we saw that the graded boost actually performs well as compared to other regressors, and also the decision tree and the random forest also provided the accuracy, but not as well as the SG, as not as well as the SG boost. And going with that, we also use that the mean squared error and the mean absolute error to judge how the models will be fitted. And with this, we looked at the 4 models, and then we did our hyperparameter tuning and got the best models and our model parameters from there. So with that, our training and parameter tuning came out well. But the one thing is that most of these outputs found out that while the mean squared error and the tests and the mean absolute error provided a good score, it is not as accurate, or it is not as accurate as compared to the multiple linear regression that we used. And this gave us the next available step, or it informed our next available step.
So after realizing that the voting regressor may not beat the multiple linear regressor score, we went straight into creating a functional API using various layers. So for instance, we came to realize that there isn't any temporal dependency in our data set. So we just focus on the permanent dependency and making sure that our neural network system can actually learn well. So you actually see here that our system has several layers, intertwined layers of like dense, dropout, multi-head attention, and expand these just to make sure that it actually learns the most out of the data. You can see we cried like 58, but just to make sure that the loss is being stabilized, as you can see on the loss chart, the creating and validation loss chart here. And we calculated the mean square error and the mean absolute error before we realized that actually they were a little better than the voting regressor, but they weren't any better than the multiple regressor yet. So we switched and decided to go into an LLM implementation.
We considered the LLM because it has access to more data than we could ever have, and we decided to use the Gemini API, which is free, in order to be able to generate predictions based on the feature engineering we did earlier. After testing this model, we realized that the accuracy was quite low as compared to the others, as it gave us an accuracy of roughly 70%. And this was an issue given all the data available because the level of randomness was too high. So we decided to not go for this model, as you can see in the next steps.
So now we went into a deployment of the linear regression as senior.
And what better way to actually showcase all our hard work than actually deploying our model? And in our deployments, one of the good things that we did was to use the label encoder. Using the label encoder, we were able to transform all categorical features into numerical values in order to be in order for them to be predicted. And also using the results from the theta mean and the theta max from the multiple regression, we were able to actually make a more informed decision on our model. And with that, we show you a demo of our website. So on this website, you can see that the employee salary prediction app will show you that the person can select their years of experience, and selecting their years of experience, they select their profession, their qualification, their country, the specialization, the company name, the job portal they applied from, the work type that they are applying for, and also whether there's a paid time off available for them, the industry, and also if there are bonuses attached to their job, and if they are a male or a female, and also the insurance policy their company is order and the headquarter their city. And with this, we can see that with the prediction that they have a salary range of $75,000, approximately $76,000 to $110,000. And with this, we can see that our model, performing with a 92% accuracy, was able to give a rough estimate of what this employee and the employer should be expecting. It will actually help them make better preparation towards their interviews because of the salary that they are motivated about. Thank you.